Hello everyone, welcome to my YouTube channel. Myself Sandhya, I am from SVC. Before getting to the topic, I request everyone to like, share and subscribe my channel. In today's session, we are going to discuss about the flat plate collectors. Let's have a look at the introduction of the flat plate collectors. Where solar collectors are heat exchangers that use solar radiations to heat a working fluid, usually liquid or air. They can classify into three groups: flat plate collectors, equated tube collectors, and focusing collectors. In flat plate collectors, there is no optional concentration of sunlight and they are generally stationary. In addition to this, their outlet temperature capabilities below 100 degrees Celsius. However, to reach higher temperatures, tube, evacuated tube collectors and focusing collectors are used. In evacuated tubes collectors, they use vacuum to reduce heat loss and to protect the absorber coating from deterioration. By this way, they can reach temperature up to 140 degrees Celsius and then they can collect both direct and diffuse solar radiation. And focusing collectors, they are not stable and they follow the sun to get direct radiation. They cannot utilize diffuse radiation and they are also capable of producing high temperature. We're flat plate collectors. A flat plate collector is basically a blank surface that is placed at the convenient path of the sun. And a typical flat plate collector is a metal box with a glass or plastic cover, which is called glazing, on top and a dark colored absorber plate on the bottom. The sides and bottoms of the collector are usually insulated to minimize heat loss. And this is the example of the flat plate collectors. The components of the typical flatbed collector is absorber plate and passages. In absorber plate, it is usually made up of copper, steel, or plastic. The surface of covered with a flat black material of the high absorption. If copper or steel, it is used possible to apply a selective coating that maximizes the absorption of solar energy and minimizes the radiation emitted by the place. But in the flow passages, the flow passages conduct the working fluid through the collector. If the working fluid is liquid, the flow passage is usually a tube that is attached or it is a part of observer plate. If the working fluid is the flow passage should be below the observer plate to minimize heat losses. And cover plate, which there are the components of the typical plate is observer plate, flow messages, cover plate, insulation, enclosures. In the cover plate, it to reduce the convective and radiative heat losses from the observer. One or two transparent covers are generally placed above the observer plate, which they are usually made up of glass or plastic. But in the insulation, there are some materials such as fiberglasses, and they are placed at the back on the sides of the collectors to reduce heat losses. Enclosure and a box that is collector is enclosed in holes. The components together protect them from weather facilitates and installation of the collector on the roof or a perforated frame. And here we can see the components of the flat plate collectors. The diagram is the cross section of basis flat plate solar collectors, where you can see the diagram. The observer plate and flow passages, where the copper, which has high conductivity and its corrosion resistance, is the material for observer plates. But because copper is expensive, steel is also widely used. For copper plate, 0.05 centimeter thick with 1.25 centimeter tube spaced and 15 centimeter apart is good thermal contact with the copper, and the fan efficiency is better than 97%. The surface of the absorber plate determines how much of the incident solar radiation is absorbed and how much is emitted at the given temperature. Flat black point is which is widely used as a coating and the absorbance of the about 95% for incident shockwave solar radiation. It is durable and easy to apply. Wait, this is a table about which metals the observer plate may be made from, and this is a table, and this is the figure diagram of which where we can see the observer plate and flow passages, the cross section of the observer plate and flow passages of the flat plate collector. And the second is cover plates, where the cover plate is a collector should have a high transmittance of for solar radiation and shouldn't deteriorate with time. The material most commonly used in glass 0.32 centimeter thick sheet of the window glass and the iron content of 0.12%, which transmits the 85% of solar energy at the normal incident, and all the glasses is practically opaque to the long wavelength radiation which is emitted by the observer plate. Like some of the plastic materials that can be used for collector glazing, which are cheaper and lighter than the glass, and because of this they used in very tiny sheets, and they often have a higher transmittancy. However, they are not durable as glass, and they often degrade the exposure of the ultraviolet radiation. And this is the characters of the cover plate materials at the table, and the cross section of the cover part of the flat plate collector diagram where you can see the cover part. And this is an enclosure or an insulation which is usually made from steel, aluminum or glass, which is in order to prevent heat from escaping through the back of collector. A layer insulation is placed behind the observer plate, and this is the diagram, the cross section of the insulation part of the flat plate collector. And this is the proper orientation of the angle, and the angle of the solar collector is the flat plate collector facing south at fixed tilt, and one axis tracking flat plate collector with the axis oriented north south, and two axis tracking flat plate collector. Thank you. Please do like, share and subscribe my channel.